What up, calculus students? Let's do this. Derivatives of e to the x. What do we learn? That the derivative of e to the x is e to the x. Tangent slope generator for e to the x is itself. It's the only function that happens for. As to find derivatives of values. What we are doing is finding the tangent slope values, finding the instantaneous rates of change. What do you have to remember is your rules. X times e to the x, derivative rule, product rule, derivative of the first times the second plus the derivative of the second times the first. Now in the future, we're going to want a factor to solve, but if I just want to plug in 3, I can just plug in 3. Now, how can you simplify all this? Well, this is 3e cubed. This is 1e cubed plus 3e cubes, 4e cubes. I'm going to zoom in some more. Yeah. All right, quotient rule. The derivative of the top times the bottom minus the derivative of the bottom times the top over bottom squared. Find r prime of 2. Plug in 2. This is the slope to this function at 2. Got 3e squareds minus an e squared. That's 2e squareds. Divided by 4. That's e squared over 2. That's the tangent slope. It's positive. Means this is increasing, right? Quick little reminders what slope values tell you. The constant in front of e to the negative x. Don't worry about the constant. You don't have to worry about that being a product. If you did it, you'd see that the first half of the product rule, the derivative of 2 is 0. You don't have to worry about it. But the e to the negative x I have to worry about. Okay? Now, if we have e to a power, and it's not just x, we need to use the chain rule. Chain rule, derivative of the outside times the derivative of the inside. So derivative of e to the power is e to the power times derivative of the power. You multiply these together. That's the chain rule of e to the power. So here I could either just not worry about the 2, leave it off, just worry about it at the end, or just put it as part of the outside. The inside negative x I have to worry about. Its derivative negative 1 to e to the power. Multiply these together. Give me b prime 2e to the, what starts in the parentheses stays, times negative 1. Might as well just simplify that to make that a negative 2e to the negative x. Plug in 5. What would I expect you to be able to do is understand that a negative exponent is the same as a positive exponent in the denominator. Now, b prime of 5 is negative. That's telling me b is decreasing at x equals 5 by this many y's per x, 2 over e to the 5th y's per x. Okay, let's remember that was the original kind of understanding of a derivative. Rate of change tells us if things are increasing or decreasing. Let's not forget that. This guy, it is not a constant though. I have to use the product rule. So derivative of the first times the second plus the derivative of the second. I need that chain rule that I just did, negative e to the negative x. Okay, pretend it's this but without the 2. The negative 1 can be moved up in front. Might as well just show it. E to the power is the O, negative x is the I. So this derivative is e to the power, this derivative is negative 1. So negative e to the negative x because I multiply these together. Times x, I'm going to plug in 2. I get e to the negative second plus negative 2 e to the negative second. What do I have? Negative 1 e to the negative second, which is negative 1 over e squared. So again, since c prime of 2 is negative, c is decreasing by 1 over e squared y's per x. That's the rate of change. Slopes are rates of change. All right, if it's something other than e, we have a new derivative rule. The derivative of a number to the x power is very similar. It starts with itself, and then you multiply by the natural log of the number. We could be doing this with the derivative of e to the x. The derivative of e to the x, you could say, is e to the x times the natural log of e. But we talked about logs and e's undo each other. It just leaves whatever the exponent is. So natural log of e is just 1, which is e to the x times 1, which is why I don't put that. But for this guy, OI, O is 4 to the power, I is the power. Derivative of 4 to the power natural log 4. X squared's derivative 2x. So 4 to the x squared log 4 times 2x. I'm going to plug in 2. That's 4. You know what? I don't want to plug in 2 because I want to show you how you can simplify this. A lot of people want to simplify this. It's, like factor out of 2, but you can't. You could plug in 1. Let's plug in 1 just for fun. If I plugged in 1, I'd get 4 to the first ln 4 times 2. I can multiply that 4 and the 2 together to get 8 ln 4. Can't do anything else besides that. You can't multiply this 4 and this 8 together. There are log properties you could use, but don't worry about them right now. Just leave this, okay? Leave that. All right, let's find f double prime. Oh, this is going to be fun. Because when I take the first derivative, I have to use the product rule. Derivative of the first times the second plus the derivative of the second times the first. Not plus, times the first. Okay. Now take the derivative again. Well, the derivative of this, product. Okay, so the derivative of the first times the second plus the derivative of the second times the first. Derivative of this, product. Derivative of the first times the second plus the derivative of the second times the first. Now, could you factor out e to the x, which we'll be doing a lot when solving equations, unit 3 types problems? Sure. But you just need to plug in 2. So I'm going to get 2e squared plus 4e squared plus 4e squared plus 4 more e squared. It's giving me a total of 4, 8, 12, 14 e squareds. That's how quickly this function is increasing 14 e squareds, y's per x, at x equals 2 at that spot. Equations of tangent lines. Okay, this is a good review. Y minus y1, m x minus x1. Point comes from the graph. So if I plug in 3 here, I get e to the 9th, right? So I start off with y minus y1, because it's the point 3 e to the 9th, equals some slope, x minus 3. Now we have to find the equation, the slope of our equation. We need to take the derivative. We need the tangent slope generator. Got to use O and I for the derivative. E to the power x squared. We've done this a couple times, so should not be surprising. E to the x squared times 2x. Plugging in 3, you get e to the 9th times 6. 6e to the 9th. Okay, there's your equation. Got this constant 2 times 3 to the x. Oh, I really want to make that 6 to the x. Can't do that. How do I know you can't do that? Well, I don't know, plug in 2. 2 times 3 squared. Is that the same as 6 squared? No, 3 squared is 9 times 2 is 18. 6 squared is 36. So if you're not sure about simplifying, you can always use numbers. Don't simplify this. Now I got to find the point. Plug in 2, I get 9. 9 times 2 is 18. Okay, cool. So that's the point 218. But now we got to find the slope. So I need p prime. Again, the 2 is just a constant. You can't be multiplying into the 3. That's the first thing. Second is you don't have to use the product rule. You can just say it's a constant, leave it alone. The derivative of 3 to the x is 3 to the x, natural log 3. Okay? Now, if I plugged in 2 to the tangent slope generator, 3 squared is 9 times 2 is 18. 18 log 3 is my slope. Cool. So y minus 18 equals 18 natural log 3 x minus 2. We're okay with this. We're okay with having that be our slope. It's going to be a decimal. If I had a calculator out, I could figure out what it is, but you don't, so don't worry about it. Cool. More of the same. But this is interesting. All right, well, again, I need the y minus y1, so I need to find my point. So I need to figure out what is q of 1/3 log 4? E to the 3 times 1/3 log 4. Okay, that's not that bad. Because 3 times 1/3, that just goes away. I just have e to the ln 4. Now, I told you guys at the beginning of class, e's and logs are like, can be thought of as like square roots and x squareds. They undo each other. They like, they're, I don't know if they're best friends or like mortal enemies. They will like get rid of the other one and just undo each other. This is something good to see. This is just 4. Okay, so you have this like 1/3 log 4, comma 4. Now, for the derivative, e to the 3x, let's be careful. OI, e to a power. I'm just going to need an extra 3. So q prime is e to the 3x times 3. Now I have to plug in 1/3 log 4 to this. This is the tangent slope generator. So again, 3 times 1/3 log 4. This is e to the log 4, which is 4. 4 times 3, that's just 12. So my point, my slope, y minus 4 equals 12. X minus 1/3 ln 4. That's it. All right. Let's find h of 2. Get 4 e to the 6th. Let's find h prime. This is a combination of the product and the chain rule. I have to use the product rule here. The derivative of the first times the second plus the derivative of the second is e to the 3x times 3. We did it in the last problem. Times the first. Tangent slope generator. Let's let it generate a tangent slope at 2. 4e6 plus e6 times 3 times 4. So that's 12e6. So 12e to the 6 plus 4e to the 6, 16e to the 6th. So I got y minus 4e to the 6th. That's my point on the graph. The tangent slope, the instantaneous rate of change, is 16e to the 6th. It's going very fast. Is f increasing or decreasing at 1? A lot of people, when they get to this question, they think that they have to do a full-on sign analysis because it's like, oh yeah, right, that tells me if f is increasing and that tells me if f is decreasing. Yeah, you're right, sure. But if I ask you what's going on just at 1, well, you just figure out what it is at 1. If it's positive or negative, you win. You don't have to do all of the work. Let's save that for when we have to, which we will soon. So instead, what we have to do is just, let's take the derivative, plug in 1, see if its value is positive or negative. That tells me if I'm going up or going down. The derivative of 1. Positive, f is going up. If it's negative, f is going down. All right, so I'm going to use the product rule. I'm not going to distribute this or simplify this at all. And for e to the 3x, the piece of the product, its derivative e to the negative 3x times negative 3. I don't even know what that is. So we got e to the negative 3x times negative 3 is the derivative of the first times the second, plus the derivative of the second times the first. I could plug in 1 into this. Record a video. You want to go over your test? Okay, so, I mean, I could plug in 1. Watch. E to the negative 3 times negative 3 times negative 3 plus 2 times e to the negative 3, giving me 9 e to the negative third plus 2 e to the negative third, which is 11 e to the negative thirds. Is this positive or negative? It's positive. E to the negative third, that's not negative. Same as 11 over e cubed, that's positive. So, since f prime of 1 is positive 11 over e cubed, f is increasing. How fast is it increasing? It's increasing by 11 over e cubed y's per x, which is not very fast. It means the slope of the tangent is very shallow, which means the graph is like barely kind of moving up. E cubed. Probably close to 27. A little bit below. 11 over 27, like maybe close to a half. Okay, same deal. Is g increasing or decreasing? Let's find g prime of pi over 3, positive, negative, and go from there. So, again, I have to use the product rule, and then I'll have to use the chain rule for both of these. If you're confused why the derivative of e to the negative x is negative e to the negative x, do O and I, and you'll be fine. So that's the derivative of the first times the second. Now, let's recall for sine 2x, it's like what we're used to with the chain rule. It's cos 2x times 2. That's the derivative of second times the first. Okay, now, what I could have done for the previous one, and I feel like I need to do here, is earlier on I could factor. Like right here. And we're going to do this a lot. Factoring out the e to the power. And then whatever's left over, maybe we could just work on that and figuring out that sign. Because we know that e to the power is always positive. No matter what the power is, e to a power is always positive. If you have a negative coefficient, then it'd be negative. But if the power is positive, negative, it's got squareds in it, it's got lots of stuff in it, e to the power is always positive. So we could have just like plugged in 1 here and then figured out that that's a negative number or that's a positive number. That's what I'm going to do here because I think this is going to be a little bit complicated. I'm going to pull out an e to the negative x. That way I don't have to worry about it. Giving me negative sine 2x plus 2 cos 2x. And now I'm going to plug in pi over 3 for fun because that's what asked of me. So I got e to the negative pi over 3 positive. Okay. And I got negative sine 2 pi over 3. And I got 2 cos 2 pi over 3. All right. So e to the negative pi over 3. Sine of 2 pi over 3 is root 3 over 2. So I have negative root 3 over 2. Cosine of 2 pi over 3 is negative a half. Times 2 is negative 1. Boom. I think this helps me just to see that I have a positive thing times a negative thing. If I want to simplify this, sure, maybe I get a common denominator. But all I know is that that's negative. So that's g prime of pi over 3. It's negative because it's a positive times a negative plus a negative is a negative. So g is decreasing. at x equals pi over 3. All right, now we get into Unit 3. We'll go back to some more Unit 2 problems later. That's an interesting question there. And this is when we're going to take the derivative, set it equal to 0. Or take a second derivative, set it equal to 0 here. Just extrema, so we need to know when f is going up and down and up. We're going to look at signs of f prime. The key to these, make sure you have the correct derivative. Factor out the e to the x. Because when you do that, you can essentially ignore this. E to the x is positive. Think of it as just a positive number. Don't let it disappear on you, especially if you have to take the derivative again. But all you have to worry about in terms of equaling 0 is the other piece of our product, giving me zeros at -2 and 0. And then when you check signs, like no matter what I plug into e to the x, it's going to be positive. This is going to be positive. So checking signs, I could plug in something like 1, positive, positive, positive. Multiplicities of these two are both 1, so the signs will change. So f is going up, flattening out, going down, flattening out, going up. X equals -2 is a max. X equals 0 is a min. Ooh, throw this one right off the bat. Okay, we'll see this a lot. So just one more time. Derivative of e to the negative x is negative e to the negative x because you have to have the derivative of that negative x, which is -1. I have to use the product rule. So derivative of the first times the second plus the derivative of the second times the first. How do I solve this equal to 0? It looks so crazy. Factor out the e to the power. In this case, e to the power is e to the negative x. Okay, so I factor that out. Leaving me with negative sine x plus cos x. See when that equals 0. Okay, so that's when, again, this is positive. Negative sine x plus cos x equals 0. Or, subtract sine, divide. You end up with tangent x equals -1. We've done this enough. We've done this one enough. So that's going to be at 3 pi over 4 and 7 pi over 4. And what I'm going to plug in? I'm going to plug into f prime that was factored right here. Just making sure. No, that's wrong. Tangent x equals +1. Negative sine x equals negative cos x. The negatives go away. Sine x equals cos x, of course. So wrong pi over 4s. Pi over 4, 3 pi over 4. 5 pi over 4. Yikes. Tangent equals 1 here and there. Pi over 4, 5 pi over 4. Okay, plugging into the simplified one, I'm going to plug in something like 0, e to the 0, +1. Sine of 0, 0, cosine 0, 1, positive. Plug in something like pi over 2, e to the pi over 2, negative pi over 2, it's just positive. Don't care about it. Sine of pi over 2 is 1, but make it negative. Cosine of pi over 2 is 0, so that's negative. And then my signs are going to change there too. Plug in 3 pi over 2. Sine of 3 pi over 2, -1. Make it the opposite, +1. Cosine 3 pi over 2 is 0. So we get that. And that's telling me f is going up, down, up. X equals pi over 4 is the location of a max. X equals 5 pi over 4 is the location of a min. Okay, same one. Same thing. Derivative of the first times the second plus the derivative of the second times the first. Set this equal to 0. We do also have to see when it's undefined, but you don't have to worry about that. Factor out the e to the x. I get 2x plus x squared minus 8. Oh, what happens? I can Rearrange this, factor this. Always positive. Don't have to worry about it. The two zeros are -4 and 2. -4, 2. Positive, negative, positive. Plug in values or no, like to the right. To the right of -4, to the right of 2, positive, positive, positive. At 0, this is a positive, positive, negative. At -5, positive, negative, negative. Okay? So F's going up, down, up. X equals -4 is a max. X equals 2 is a min. Okay. All right, now we're going the next level. When it's F increasing and concave down, we not only need a first derivative sign analysis to tell us about F going up or going down, but we need our friend F double prime and its sign analysis. So we know if F prime's going up or going down. So we know if F is concave up or concave down. So here we go. Derivative of the first times the second plus the derivative of the second times the first. Use parentheses. Factor. This turns into 2x plus 3. So I get -3/2. E to the x is positive. Positives to the right, negatives to the left. You can check your signs. So F is increasing right over there. Let's look at our second derivative. Now, it's up to you when you want to take the derivative. Again, I like my factored form to take the derivative of that. Now, back in Unit 3, we did not like to take the derivative of a factored form. We used to just take the derivative first and then go straight into the second derivative. So we'd take the derivative off of this step. This is different. It's probably better if we, it could be better. It's going to give you the same result. But I prefer to wait till it's here. That way it's less things I have to do. I just have to do one product rule versus taking the derivative of this and then taking the derivative of this using the product rule. So I'm going to go here. And this is the derivative of the first times the second plus the derivative of the second times the first. Again, we want to see when this is 0, factor out the e to the x. I'm left with 2x plus 3 plus 2. That's 2x plus 5. And I get -5/2. Check the signs. E to the x is positive. I'd have positive, negative. The answer's never. I think we had a couple like these on our homeworks. Some nevers where it's like, Mr. Messer, bad question. Probably I would ask you, when is F decreasing? Concave up. Here's F decreasing. Here's F being concave up. So I would say probably on the quiz, to make sure you got the right, some numbers for answers, that. Now, we haven't done this yet, but I'm going to graph just so we can see our analysis. We haven't really looked at any of these yet, but it's fun sometimes to see our human graphing calculator capabilities. So 2x plus 1 times e to the x. It's rewarding when we look at graphs. It's like, what? It looks like it's just going up, right? And adjust my window a little bit. I'm going to look at between -5 and maybe 1. I'm going to shrink my y's to be between -3 and 3. Let's see if that's going to look better. Oh, okay. Hold on a second. What did I say? F's got to have a min at -1.5. Oh, look at that. It's a min. F is decreasing concave down until -2.5. Decreasing concave down until here. There is a point of inflection here. And maybe if I zoomed in more, you'd see it, but probably not, honestly. Concave down, and then we switch to being concave up, decreasing. It's tough to see. But then we increasing concave up after -1.5, and boom, there we go. So really cool we were able to do that uh, analysis. All right, this is the same deal. We're finding extrema, points of inflection. When is the function increasing concave down? Very similar to that question. I mean, it's the same as that question. It's just maybe more detailed. So first derivative, we've done this a lot, actually. It's a popular one to look at. And you get -1. I think this is in your notes. Positives, negatives. So we have a min at -1. Let's look at our second derivative. We use this derivative to go off of. A lot of times we didn't do that last unit, but I like it. Derivative the first times the second, plus the derivative of the second times the first. Again, factor out the e to the x. 1 plus x plus 1, giving me 2 plus x. So for our second derivative, we're looking at -2. Positives, negatives. It's another never. Oh, man. F is going down, then going up. F prime is going down, then going up, which means F is concave down, then concave up. X equals -1 is a min. X equals -2 is a point of inflection. Increasing concave down, never. We say F is decreasing concave up. Maybe I ask you that question from -2 to -1. I hope I fixed the quiz questions. All right, good. We got one more question, and then we got a bunch of table problems, which is really unit 2. It's a good, hey, challenging problem, changing things up here. We're told that this function has a critical point when x equals 2. Find k. Okay, it's important to know that k is a number. Okay. You see this question on your quiz. Okay. So heads up, I think. Yeah, pretty sure. So let's get ready. All right, critical points are when derivatives equal 0. But I'm told that at 2, I have a critical point. So here we go. When I take the derivative of this to get f prime, and then I plug in 2, that should equal 0. That's how we're going to do this. Very simple. It's not that bad. It's different, but you guys shouldn't be memorizing processes. You should be understanding what you're doing. So it's a product. These are product rule. Derivative the first times the second. Plus the derivative of the second. Now, what's the derivative of e to the kx? Well, think of k as a number. I don't know. Think of k as 3, just as an example. E to the 3x. Well, we took the derivative of e to the 3x before. It's e to the power times 3. Well, if this was k, it'd be e to the kx times k. So that's what we have. Just like e to the 3x. And then derivative of the first times the second plus the derivative of the second times the first. Don't forget this. A lot of people, when you use the power rule and the product rule, you leave off pieces of one of them. Okay. Now, when I plug in 2, this equals 0. So I get 4e to the 2k plus e to the 2k times k times 4. This should equal 0. All All right, this is a simple equation to solve. Factor out the e to the 2k. This never equals 0. E to any power is always positive. You get 4 plus 4k equals 0. K's got to be negative 1. And that's it. K has to be negative 1. We have a critical point at x equals 2. All right, so that's unit 3. Now we go back to unit 2 and these table problems. We just have to remember our derivative rules. Notation matters. Get some information from our table. There's no graph on this one, so you're lucky, but hopefully we're not uncomfortable with those. It's just the information. 2e to the f of x, o and I would say 2, or just leave the 2 out and worry about it later. 2e to the power is the o, I is the function. Giving me 2e to the f of x times f prime of x. I want to find g prime of 2. So it's 2e to the f of 2, which is 0. F prime of 2 is negative 2. E to the 0 is 1, so this gives me negative 4. Table problem. J prime. Derivative of the top times the bottom, minus derivative of the bottom times the top, over the bottom squared. It's really important. E to the x squared could be written as e to the 2x, right? If you have a power to a power, you multiply the powers. This is something to keep in mind with e's and logs. That's important. I feel like I should be better than that. This is f prime. This is f of x. All right, plugging in 3. I got 2 and negative 3. So this is negative 3 e cubed minus e cubed, what was it? 2? 2 over e cubed squared, which is e to the 6th. Ooh, good one. So what happens there? I get negative 3e cubed minus 2e cubed, which is negative 5e cubed, over e to the 6th. I can simplify that. Cancel 3 of the e's, it's negative 5 over e cubed. That's something that I'd want you to get down to. Okay, got it. F times e to the x, got to use the product rule. Derivative of the first times the second, plus the derivative of the second times the first. Plugging in 3. F prime of 3 is negative 3. F of 3 is 2. So this is negative e cubed, or negative 1e cubed. X e to the f. Ooh, I got a product and a chain. Derivative of the first times the second, plus the derivative of the second, o, I, e to the power. E to the power is derivative of e to the power, f's derivative, f prime. E to the f of x times f prime of x times x. So derivative of the first times the second plus derivative of the second times the first. Plug in 1. F of 1 is 3. F prime of 1 is negative 1. So this is e cubed. This is e cubed times negative 1 times 1, because we're plugging in 1. So e cubed minus e cubed. Look at that. 0. Good one. Any other number to a power? O and I this. 3 to the power f of x. The derivative of 3 to the power is 3 to the power natural log of the number. Didn't have many of these, but whatever, it's fine. It's usually not many of these on the actual AP test. It's focusing more on ease. Okay, so 3 to the f of x, natural log 3, times f prime of x is the derivative of h. Minus 3, well, the derivative of 3 is 0. Threw that in there just to mess you up. Plug in 1. What's f of 1? 3, f prime of 1, negative 1. So 3 cubed, ln 3 times negative 1. 20, negative 27 ln 3. At 5, at 4, you want to multiply them together. Don't do it. It's just part of the outside. 5 times 4 to the power, or it can just be left off. Constants can be left off. The derivative would be 5 times 4 to the power ln 4. Again, like almost you can ignore the 5 to begin and then bring it back in afterwards. And then the f prime here. So p prime 5 times 4 to the f of x ln 4 times f prime of x. Plugging in 2, f of 2 is 0, f prime of 2 is negative 2. So f of 2 is 0. F prime of 2 is negative 2. I just have 5 times 1 times log 4 times negative 2, which is negative 10 log 4. Okay. Sure, I made a mistake somewhere, but maybe I didn't. Anyways, tricky ones, but once you get used to it, you realize it's not that bad. Just got to pay attention to your derivative rules. Peace.